Hello students, now we shall see some properties of surface integrals. Just like line integrals, you have similar properties for surface integrals. The first property says that if you have two real valued functions g1 and g2 defined over the surface S, then g1 plus g2, g1 minus g2, these two are well defined, and double integral over, this is not the double integral, this is the surface integral. Surface integral over S, g1 plus or minus g2 d sigma equal to the surface integral of g1 plus the surface integral of g2. Property 2 says if c is a real number, then the surface integral of cg is the same as c times the surface integral of g. Third property says, it's called additivity property. So if a surface S is a finite union of non-overlapping patches S1, S2, etc. Sn, then the surface integral of g over S is the same as surface integral of g over S1 plus etc. plus surface integral of g over Sn. So how such a patch will look like? Suppose I will draw a figure. The simplest case, suppose you have the roof of a house. This is one patch, another patch is this patch is, so this is the roof of a house. This is S1, this is S2, and these two are non-overlapping. So integral over S1 union S2, that means over this whole roof S, is integral over S1 plus integral over S2. And fourth property says, if g greater than or equal to 0, then the surface integral of g over S is also greater than or equal to 0. We shall see an example. Integrate g of x comma y comma z equal to x into y into z over the surface of the cube cut from the first octant by the planes x equal to 1, comma y equal to 1, and z is equal to 1. So what does the problem say? First you have a cube in the first octant. This is x, this is y, this is z. X equal to 1 is here, y equal to 1 is here, z is equal to 1 is here. You have these three planes. All these are planes. So you have a cube determined by these three planes, and it is cut from the first octant. That means you have the cube like this. Oh no, this is a very bad figure. Now let us okay. Yeah, okay. This is the origin this is side A, this is side B, this is side C, this is side D, this is side E, that means in the YZ plane, and one more side you have that is, I cannot draw that because that okay, I think side B is this. I will remove this. I don't. This not side B. Side B is the side which we see the cube. So this is side B. The front face. Side B is the front face. Side A is the upper face, and side C is the side face. 3 other sides you will have, but I am not going to mark it. So now you want to integrate the function. Which function? G of x comma y comma z equal to x into y into z over the surface of the cube. So S is equal to side A union side B union side C union side A union side B union side C union side D union side E union side F. Okay. So surface integral over S G d sigma G d sigma equal to surface integral over side A G d sigma plus surface integral over side B plus surface integral over the side C plus surface integral over the side D plus surface integral over the side E plus surface integral over the side F. Okay, G d sigma is here, everywhere. I am not going to write it. Now look at the surface. Look at the side D. If this is the side D, then here y equal to 0, right? Y equal to 0 on side D. So xyz equal to x into 0 into z equal to 0. So surface integral over D will be equal to 0. Similarly, look at side E. Side E is the back side, let us say. Side E is the back side of this cube. So side E in the back side. So there x equal to 0, because that is the YZ plane. When x equal to 0, xyz becomes 0 into y into z equal to 0. So surface integral over E is also going to be equal to 0. Similarly, look at the side F. Let us say F is the bottom side. F is the bottom side. So here z is equal to 0. So xyz is x into y into 0 equal to 0. So surface integral over F, this is also going to be equal to 0. Are you getting? So now let us look at integral surface integral over side A. So surface integral over side A, G is xyz d sigma equal to Now what is side A? Side A is this. So this is the plane, z is equal to 1. Side A is the plane, z is equal to 1. So xyz becomes x into y into 1. So x into y into 1 d sigma over side A. But what is d sigma? It is norm of del f divided by norm of del f dot p dA. Here you have your function x into y into 1. It is simply xy. Then here it is d sigma. That means it is the surface integral. Now here I have written dA. That means this is the double integral. Double integral. What is the shadow region of side A? What is the shadow region of side A? If you are applying a torch from here, shadow region of side A will be this square in the bottom. That means the side F. So that is your shadow region. It will be denoted by R, where R is the rectangle rectangle 0 less than or equal to x less than or equal to 1 and 0 less than or equal to y less than or equal to 1. Okay. Now what is f? F is the surface, z is equal to 1. Here this is the surface I am looking at. The side A is my surface for the time being. So the surface is f of x comma y comma z is z is equal to 1. So what is del f? Del f is precisely dou f by dou x, dou f by dou y and dou f by dou z. So del f is, as far as the side A is concerned, del f is dou f by dou x. It is 0, dou f by dou y, it is 0 and dou f by dou z, it is 1. Why is that? Because f is, z is equal to 1. This is the level surface. Z is equal to 1 is the level surface. And what is the vector? Vector P. It is the vector perpendicular to the shadow region. So unit vector perpendicular to the shadow region, P can be taken as vector K. P can be taken as vector K. So norm of del f is equal to 1. What is del f dot P? Del f dot P what is K vector? K vector is the same as 0, 0, 1. So what is del f dot P? It is again 1. So norm of del f dot P is also equal to 1. Therefore LHS is equal to iterated integrals. Do you remember iterated integrals? A double integral can be evaluated as an iterated integral. So x varies from 0 to 1, y varies from 0 to 1, then xy into norm of del f is 1 divided by norm of del f dot p, that is also equal to 1. dA is dx dy. Understand? So this right side is the double integral, and the double integral is now written as this iterated integrals. That is what Fubini's theorem says. So now you have to integrate this. So you integrate this first with respect to x, keeping y fixed. So what you will get? X square by 2 into y equal to x square by 2 into y between x is equal to 0 to 1. So you have integrated with respect to x. Now integral with respect to y remains. Y varies from 0 to 1. So that is equal to integral y varies from 0 to 1 by 2 y dy, because you have substituted the values for the lower and upper limits for x. So you will get 1 by 2 minus 0, namely 1 by 2. So this is equal to 1 by 2 into y square by 2 between the limits y is equal to 0 to 1. So what you will get? 1 by 4 into 1 minus 0. That means 1 by 4. So this is the value of the integral over the side A. Understand? Similarly, integral over side B, you can compute. This is because of symmetry. The integrand is symmetric with respect to x, y and z. If you replace x by y or z and y by x or z and z by x or y, the function is not going to be changed. So integral over side B g d sigma equal to, again you will get 1 by 4, and integral means surface integral over side C g d sigma, that is also equal to 1 by 4. Hence surface integral over S g d sigma equal to integral over side A plus integral over side B plus integral over side C plus 1 by 4 plus 1 by 4 plus 1 by 4 equal to 3 by 4. This is going to be the answer. Thank you.